So in the last three lectures, we have already solved two programming exercises, and I believe that you have actually write those codes by your hand. Otherwise, you will actually forget if you don't write it by your hand. You need the practice. One other thing that we actually add here is equal AB. It will actually provide the whether A and B is equal or not. Now, I didn't actually go into details in the last lecture, so let's take a look at here. uh, I have already written something. So if we check here, so for example, if I write 5 is equals to 6, it is giving me this logical 0. And I have already told you logical 0 means it is false, obviously. But when you are actually using this uh, character array, so if you use like mn, okay, it is giving me something like this. Okay, 0 0. It is actually matching for each index 2 by 2. It is matching a with m, it is matching b with n. If I do it something like this one, I get 0 because a is not equal to m, but b is equals to b. So this, it is giving me 0 1. But the problem is if I write something like this, now I get an error. The error is matrix dimension must agree. That means when we are using this double equal sign to actually check whether both sides are equal or not, this side and this side has to be equal. Okay. When you are using this numeric array, that's always equal. That's not a problem. But when you are using this character array, that is actually a problem. So whenever you are using this character array, you cannot use this double equal sign. So what you can use this is equal sign. Okay, if you use this is equal, if they are not equal size, then it is okay. It will just give me a 0. But if you write something like this db, it is still giving 0 because it is not checking by element wise. Now it is checking the whole one as single one. Are you clear? So this is for character array. I believe it's clear now. So is equal matrix. Now I want to show something else as well. Let's do something interesting. Now as you can see, instead of writing a character array, if we write a string, now it is actually this double equal sign is still okay. Now this is actually one of the scenario. That's why I actually asked you to actually install MATLAB 2017 or later, because the string actually provides different options than the character array. But still, if you have not installed, if you cannot install 2017, that's completely fine. Just watch these things. So I believe the is equal option is clear. Later on, we'll see many is equal or something, this type of function later on. So this is your problem exercise 1 and problem exercise 2. Now, before going to the next exercise, I want to talk a little bit. Okay. The thing is, we have used the for loop and the conditional statement. If you still have some problem with that, just practice a little bit by yourself. They will become very clear. But the thing about this one, especially the for loop, is that we are in MATLAB, since it is a very high level programming language, we actually try not to actually write for loop. Okay, instead of writing a for loop, we do something different. Okay, that is what we call vectorization. Okay, vectorization, and this is one of the most powerful technique in MATLAB, which is not provided by many other programming languages. Does not provide this option, but MATLAB actually provides this vectorization of vectorization approach, and it is actually very easy to use in MATLAB. Okay, so what is vectorization? Okay, and how and why do we need vectorization? So let's try to explain that one first. Okay, I'm going to pause this video to write the program first, so it will become much more clear to you. All right, so vectorization. So I have created this new M file. So I have used the same code, the one we actually did for counting the number of maximum elements, the same code, and I have write something interesting here, tick and talk. Okay, now tick talk, actually this function actually provides the time to run this, whatever within, to run this program, what is the time it requires. Okay, so now x, I want to define x in a different way. Let's define it. So let's do it with 1000. So you don't have to know what is I'm actually writing here for now. That's completely fine. You don't have to know it for now. Okay. So this is my X. Now X is an array with 100,000 elements. Again, X is an array with 100,000 elements. Okay. Previously it was 5 or 6 elements that we are working on, but now it is 100,000 elements. And I want to run this code, that is the maximum number of, okay, so max of X is 500. Okay, that's completely fine. Now what I want to do, how many times this actually appeared in this array. So I am writing this, this code is already written, and let's run this code. And you see it is actually busy. It is actually taking some time to calculate. And you can see the elapsed time is 5.08 second, and this 500 actually appeared 188 times. If you go here, and these are all are the values of X. Okay, this is huge lengthy array. So when you have this lengthy array, it is very difficult to actually visualize the data. So we have to just code, write a program for it. And as you can see, it actually took 5 seconds, and that is actually very large for a simple program like this. For a counting operation, that actually very large. So we want to make this code run much faster than that. Okay, so that is where the vectorization comes in. This is the for loop that actually make this program run so much slowly. Okay, also you can try another thing. I actually told you to use this semicolon here. If you don't use semicolon and run this function again, you will see it will take much more time. Okay, I can also do it here, but it is going to just take some time. Let's see. Okay, so it is actually showing this count variable. Wait for some time. So this is 5.62. What was the previous value? I forgot. It was 5.08. Now it has become 5.62 seconds. So remember the time. So this is actually very lengthy. We want to write our code normally within the millisecond, not in the second range. Okay. So what we can do is something that is called vectorization. The vectorization code will remove this for loop. Okay. So I have already written it here. So don't worry what is here within, what is inside this. I will actually explain these things a little bit later. So let's run this code and see. I'm running this code within the same X, okay, same 100,000 long variable. Okay, but now we can see it is only taking 0.003 second. So if you actually compare between these two, 5.62 second and 0.003 second, that's the huge advantage. Okay, the time complexity has reduced very a lot. Okay, so vectorization is a super powerful approach in MATLAB that we can actually implement to make your code run much faster. And this is a very essential skill that you need to earn. That's why I'm teaching you a bit earlier stage, but I think that will be very helpful for you. So if we just try to compare here, so if I just write it here, vectorization compare with for loop. Okay, so here I actually needed 5 seconds, for example, like 5 seconds. Okay, here I am taking 5 milliseconds or some lower, even lower than that. That's like 1000 fold. Okay, that's like 1000 fold. Okay, increase of time. So vectorization is one of the most important skills. So you need to understand how to write vectorized code. So let's try to explain what we are actually doing. And please try to give much concentration here so that you can actually understand what we are actually trying to do. So let's start with this one. This is my A. So it is containing 5 elements, 3, 5, 8, 7, 8. And 8 is the maximum element. We already know. So what we'll write for vectorizing is that uh, we'll write this code. A is equals to 8. 8 is the maximum element. We'll write this code. Okay, so you can see we have not written any for loop here. So instead of writing this, let's show you here. It will be much easier for you to see. So let's 3 comma 5 comma 8 comma 5 6 comma 5 comma 8 comma 9. Let's give it some elements. So it contains total 7 elements. Okay, so I am going to write A is equals to max of A. Okay, so when I write this code, so what is actually happening here, so understand, I'm using this equal sign, double equal sign, but I am not explicitly writing a for loop to go through each element one at a time. rather than I'm writing this whole condition in a single line. Okay, there is some linear algebra technique, okay, very advanced technique that can actually do this stuff. You don't need to understand all the details of these things, but what I am getting here, see, 3, is this equals to maximum a? No, so it is actually giving me 0. Let's actually change it a little bit, it will become more sense. I place another 9 here, okay, then write it again. Now, so 3, it is not, the maximum is 9, so 3 is not equals to 9, so 0, 5, 0, 8, 0, 6, 0, 5, 0, but 9, this is the maximum element, so it is giving me 1. Then again 8, it is giving me 0, and then again 9, it is giving me 1. So this is my logical array. So this is actually checking whether it is true or false. That is the logical indexing. Okay, this is the third type of indexing. Let me tell you later. So this is what we actually did. X is equals to maximum of x. So it is actually returning this array. And now I want to just sum this array. If I sum, I will get 1 plus 1 equals to 2. So I can easily say 9 actually appeared 2 times. It is that simple. Okay, how many times I have 1? Because all the others will be 0. Because a logical array can contain only 0 or 1. 0 for false, 1 for true. How many times it actually became true? That is the how many times I had maximum element. So if I just sum over this answer is by default. If I don't write anything, it is by default actually saved in answer variable. Okay, so sum is 2, so actually it appeared 2. Similarly, what I did, sum is equals to whatever inside. Okay, so this is actually a very powerful technique. So please actually pause the video and take a look at it again so that you can actually understand properly. So let me show you here. So what we are actually doing, we are writing this code, a is equals to 8. So this is actually giving me a false, that means 0, then again 0, then I have a 1, then again 0, then again 1. So this is my output. Okay, this is my output from this line of code. Okay, so let's name it another one, B. Then I'm just going to sum over this B and it will give me total 2, and that is my answer. So this is a simple vectorization code. So what is actually making all of this thing? That is that we are no longer using a for loop to go by one. Okay, so going for one by one, that is actually creates the problem. So we are not doing that. So that's actually what the vectorization is doing. Later on in many exercises, you will see the vectorization will start to become more and more clear. Okay, so I hope this is clear for now. If it is not clear, please see this video again, because vectorization is a very important skill that you should have up on your syllabus. So one other thing that I wanted to talk about that is in the last class, okay, I have talked about linear index, then I talked about subscript. Okay, then this is the third type of indexing, that is called logical index. Okay, logical index, let's give it a pause. So in case of linear index, it actually provides a integer value. If you remember, it provides an integer number. Okay, so in case of subscript, it provides a in Python we call it tuple. Okay, but or tuple, whatever. So it actually gives me 1 comma 2 or 3 comma thing, that is a subscript. In logical index, it will provide true or false, 0 or 1. Okay, and this logical indexing is the most useful because we can actually use this one very efficiently. Okay, how much efficiently you can use it will actually make you much better programmer. That's it. Okay, so this is a very useful technique. Now before I actually wrap these things up, let's solve our problem. Our here the exercise, let's actually use this. Which one was? Yes, this is the 55. Okay, so for example, the last question was which department has 55 students. So I was taking here. So let's I believe we already have the IUT. So this is my IUT data. I wanted to know which data had 55. I just wanted to know which one was 55. So I can just simply use IT is equals to 55. Then I get 0 for all of those things and I get just 1. And I just need to know which is the index, what is the index of 1. Okay. Now there is another built-in function. What we can actually do, just type find answer. It will give me 4 automatically. Okay, this find will actually provide the index for this true or 1. Okay. If it is very it is actually looks very complicated, don't worry about it now. In the later problems it will become much more simpler. I will be using this find again and again and again, so don't worry. Just for now, just let me write it here. So we have learned how to write a vectorized code, and we have learned a new function that is called find. Okay, the find is actually doing, whenever I have something like this way, find will actually provide the index for this 1. Find will provide the index for 1. Let me show you again. Let's write something like this: 0, 0, 1, 0, 1, 0. Okay, if I write find b, as you can see, when you have 2 1, it actually providing 3 and 5 both. And this was a problem that we actually faced when we are actually solving these types of problem, this for loop, writing for loop. We are unable to use our normal function because there are multiple inputs, multiple outputs. But if you use find, you will get the multiple outputs, uh, both the multiple outputs, even if it's 3 or 4, everything. So that's a very huge advantage. So find is another built-in function that is going to be proved very useful. Okay, so I hope it is clear for now, and you can actually now try using this vectorization approach for your experiment, for your exercise 1 and exercise 2, and you will see you can solve those problems much more efficiently. Okay, and try it by yourself, and if you don't actually if you are unable to do it, just knock me. I will actually help you in that. Okay, so let's wrap this one.